So let us try to solve this problem in this class. Show that the electric field at the surface of a the electric field at the surface of a charge conductor is given by E equal to sigma by epsilon naught into n. Show that the electric field at the surface of a charged conductor is given by E is sigma by epsilon naught n, where sigma is the surface charge density, and n is the unit vector normal to the surface in the outer direction. N is the unit vector normal to the surface in the outward direction. Show that the electric field at the surface of a charged conductor is given by E is sigma by epsilon naught into n, where sigma is the surface charge density and n is the unit vector normal to the surface in the outer direction. Now let us consider a charged conductor, and let plus q is the charge which is uniformly distributed over the spherical shell. So to show that E is sigma by epsilon naught into n on the surface of the conductor. So like let us consider, let q be the charge uniformly distributed over the spherical shell of radius r. So consider a spherical shell of radius r and we have assumed q is the charge. Q charge is uniformly distributed over the surface. And if I consider a small area over here, so the electric field is, because it is plus charge, the electric field is going normally outward. and ds is also along E. And also given unit vector n. These are all parallel to each other. So a spherical shell with charge q uniformly distributed over the surface. So we know that the electric field intensity on the surface of spherical shell is given by one by 4 pi epsilon naught into q divided by radius square. So radius here we took it as r, so r square into unit vector n. Now E acts along radially outward and along n. Now given the surface charge density is sigma, given surface charge density is sigma. So sigma is charge by surface area, that is q by 4 pi r square. So in the electric field equation, if we substitute q by 4 pi epsilon naught, q by 4 pi r square as sigma, we get the required equation. So therefore E is 1 by 4 pi r square into q by epsilon naught. So in this substitute the value of sigma. Sigma is q by 4 pi r square. So this value is sigma. Therefore we get, so here multiply by unit vector n. So substitute q divided by 4 pi r square equal to sigma. Then E equal to sigma by epsilon naught into n, and this is what the required equation. E is sigma by epsilon naught into n. E is sigma by epsilon naught into n. That is the required equation. So you can remember one thing here. So this is a note, a general note. So the electric field E is directed outward if q is greater than 0. In our case q is positive, or E is directed inward if q is less than 0. So E is So E is directed inward if Q is greater than 0, E is directed inward if Q is less than 0.